This is segment 11 of the Module 7 lecture, and this is the last segment. In this, we will talk about how to determine the minimum sample size. And we're going to first see the minimum sample size required based on for the population mean. In the second part, we'll look at the minimum sample size to estimate the proportion. So in here, to estimate the sample size, or rather to determine the sample size to estimate the population mean, we rely on the margin of error. And here we assume that the population standard deviation is known. So from this expression on the margin of error, you can do some algebra, and then you will find that the sample size is given by this equation. And this is the sample size for a given level of confidence, 1 minus alpha, and for a particular level of particular margin of error. All right, to do this, calculate this sample size, we need to determine what is the significance level that we require, what is the absolute, or rather the error about the estimate, and we need the value of the population standard deviation. So the levels for the significance and the margin of error, those are established based on practical requirements. And the standard deviation, of course, is not known because we will have to study the whole population. So what we do here, we look at historical data, or from experience, or from a small sample, we estimate the population standard deviation. And using that information, then we can calculate the sample size. Here's an example of how we do this. So an inspection division of a county weights and measures department wants to estimate the mean amount of soft drink fill in 2-liter bottles to within plus or minus 0.01 liters with 95% confidence. It is assumed that the standard deviation is 0.05 liters. So here, what is the minimum sample size needed to estimate the population mean? Well, the margin of error is 0.01. The confidence level is 0.95. And from there, we find the z-value, as we've done for the confidence interval. So 1 minus alpha over 2 is 0.975. That gives us a positive value of z. And the population standard deviation, we're told that is to assume that is 0.05. All right, so with these numbers, we then put them into the equation for the minimum sample size. And so z is 1.96, the standard deviation is 0.05, and divide that product by the margin of error. We square that, and you get 96.04. And remember, once you calculate the sample size always rounded up. So in this case, in the interpretation of this result, we said then to achieve a margin of error of plus or minus 0.01 liters with a confidence level of 95%, a minimum of 97 bottles will need to be randomly sampled. So we rounded this 96.04 to the next integer, which is 97. All right, now let's look at the example of how we calculate the sample size to estimate the population proportion, or the probability of success. Again, using the expression of the margin of error for the sampling distribution of the proportion, then we, doing some algebra, we find what n is equal to. And here's the expression of the margin of error. And to calculate this sample size, we need the significance level, we need the margin of error, and we need to know the probability of success, which is, of course, unknown. And so we have two choices. We can perform a small pilot study to obtain an estimate of pi, or we can select pi equals to 0.5, which is, we produce the largest possible sample size. This is called the conservative approach. All right, so let's look at an example and see how we get the sample size. So how do consumers feel about companies sharing or selling their personal data? A Bain & Company press release, you can find the information here, reports that a new survey they conducted found that 67% of consumers indicated that it would be illegal for companies to collect or use such data without getting prior consent. So we want to conduct a follow-up study that would provide a 99% confidence that that point estimate is correct within 0.03 points of the population proportion. So how many consumers do we need to sample? So if we use a probability of 0.67, what they found in this study, and we want to use a pi of 0.5 and compare the sample sizes. All right, so let's look at the first situation. So the margin of error is 0.03. The level of confidence is 99% or 0.99. So again, doing what we've done before, the alpha that is outside is 0.01 divided by 2 is 0.005. And the probability to the left of this probability is 1 minus alpha over 2 or 0.995. That will give us the positive value of the z-value. So from table 4, using this probability 0.995, you find that the z-value is 2.575. So that together with the margin of error and the pi value of 0.67, then we put them into this equation, we do the calculation, and we find 1,628.9, or rounding up, 1,629 people need to be interviewed. All right, let's look at the example where pi is 0.5. Again, we use the information that we had, except that pi now is 0.5, and that gives us 1,841.8, rounding it up to 1,842. So to obtain a point estimate that is within plus or minus 0.03 points from the value of pi with a 99% confidence using a pi of 0.67 requires to interview at least 1,629 individuals. However, the conservative approach will require interviewing at least 1,842 individuals. So if you didn't know pi and you went with a conservative estimate of 0.5, the required sample size will be larger, but not too large. All right, with this we complete the discussion of all the topics in Module 7. And so then probably you see the first part of the Module 7 assignments are posted, and then the last part will be posted, is posted and is due next week. So the first part of the Module 7 homework on Wiley Plus is due this coming weekend, and the last part of this module is due next week. And you can see this when you go on to the Wiley Plus website and look at the calendar. All right, at this point, you should be able to explain what the sampling error is and its effect on estimation. You should also be able to explain the non-sampling error. And you should be able to explain what a sampling distribution is and the characteristics of the sampling distribution of the mean and the proportion. You should be able to calculate a point estimate for the mean and the proportion. You should be able to calculate an interval estimate for the mean and the proportion. And you should be able to interpret that confidence, that's interval estimate for the mean and the proportion, as well as the point estimates. And finally, you should be able to calculate the minimum sample size to estimate the population mean and the population proportion for a given level of confidence and margin of error. So this is it for Module 7. So next week we'll continue with for the last part of Module 7 and then move on to Module 8.